My name is Jacob Komarovski, and I work at Expolog. And Expolog is a log analysis and management system. What this basically means is that we collect data, log data from our customers, we input it into our system, we then analyze and augment this data and allow users to search and analyze their data and get meaningful insights. We've been around for a while, for more than a decade now, and we are enterprise ready with everything that this entails. What our customers usually do with Expolog is they analyze their logs, they search in them, they do root cause analysis, and they identify bottlenecks, and so on and so on. Most of us here are developers, and at one point in time, we probably found ourselves sitting at 2 a.m. in front of a log file, looking something like this, and trying to understand where this critical bug is coming from, and we just felt so helpless, or at least I did. And programs like Notepad didn't really do the job. So a decade ago, companies like Expolog started releasing search engines. They usually look something like this, and they allow you to better understand your data. They allow you to drill down and analyze it even further. And it's very nice, it's very convenient. Some of us have already moved to this kind of approaches, but we think that it's not enough, and we propose a better way to do it. Imagine that you could see and feel the data as you actually see it in your mind. Imagine that you can interact with it. You can see it in front of your eyes, and imagine the data looking something like this instead of logs or tables. Using a graph, we can better visualize the data. We can augment it, enhance it. We can color it, use shapes, and many other applications. After deciding to use a graph engine in our application, we investigated all the possible solutions out there. And Redis graph was one of them. We decided to choose it because our application is user-driven. This means that user creates actions, they want to find something, they want to search something, and they want it now. It must be super fast. Redis graph is in memory, so that's a big plus for us. The data model that they use inside the Redis graph, like Roy explained earlier, is very flexible. It allows us to add attributes to nodes and edges. We can model the data as we see fit. The second thing is that Expolog is an on-premise solution, which means that easy deployment is a must for us. We already use Redis in parts of our application, so that was a no-brainer. The community is very big, as we can see here, so that's a big plus for us. So part of it, I assume, is because of this kind of conferences, so thank you for this. And let's delve a little more into Expolog itself. Our data flow consists of 4 main sections. The first one is collecting the data. The second is processing it and augmenting it. The third one is visualizing it and making it accessible to the user. And the last one is automation processes that run in the background and perform more advanced algorithms that run graph theory applications and extract more meaningful information. The graph can be added as another layer of processing and visualization that we hope will ease our jobs. Let's look at a particular example. Let's take Log4j. Log4j is a pretty well-known Java logging framework. And we decided to take a log from Log4j and input it into our system. That's just an example. We can input any kind of log that we want. The main flow goes like this. We take the log, we parse it, and we structure it. Then we create a temporary logical model that we call XPLG graph. And that model is written into Redis graph, into the database. On the other side, we have our UI model extracting data from the database and finally visualizing it and making it accessible to the user. Let's delve a little more into, let's dive in. And the first part is very complex to explain. I'll do my best. Basically, the data is unstructured. All of us here, we can write any kind of log that we want. We can write anything in this log. It can have any kind of structure. So we extract the data from it using very advanced statistical models and other advanced methods. And together with a special graph configuration file that I will explain a little later, we create our XPLG model. This is a temporary logical model that helps us model the data as we see fit. And then we write this data into Xpolog, into Redis graph. Inside this graph configuration file, we define everything that we need in order to build the graph. That's why it's completely generic. We can build a new configuration file in a couple of hours, and we'll have a totally different graph structure. Inside it, we describe how a node will look and be represented, how it will be written to Redis graph, what are the edges or connections between these nodes, and how will the user actually see them at the end. Adding data to the graph isn't very simple because we need to find a good way to model this data. We did some testing and we decided that for our use cases, we will model every real-world entity as a node in the graph, exactly one node. So for example, a real-world entity can be a user or a system, server, or any kind of application. And then any kind of transaction between these two entities will be represented as an edge in the graph. So if a user performs a login operation on a remote server, we can create an edge between these two entities, and this will be represented in the graph. Our use case, basically for us, usually we will have a lot of new nodes at the beginning, a lot of new entities, users, threads, class types in Java, for example, and anything else. And later we'll just have more and more and more interactions between these entities. So after a while, most of the nodes won't be new, and we will only be left with new edges. After doing a lot of testing and trial and error, we got to the conclusion that we need to constantly create small graphs, these XPLG temporary graphs, and write them into the big graph inside Redis. And we do it by creating every node exactly once, by merging every node once. And then we create all the edges at one go. This helps minimize the time we need to do it and saves on performance, increases performance and saves on network. A few things to think about are that nodes should be cached as they will be repeating themselves quite often. So this can be done by Redis, for example. That's a very popular use case. After a while, almost no new nodes will be merged, and the speedups will be huge. Basically, graph merging is quite challenging. Our backend is written mainly in Java, but like Roy said, Redis graph is communicated with by using Cypher query language. Cypher is a graph database query language, like we have SQL and stuff like that. And we need to convert every Java object into this Cypher and back. So we do it by creating an abstract syntax tree from every Java object. And then we parse it and create a Cypher query that we can later send to Redis. We are building on top of a few open source projects like JCypher and JRedis graph. And take a look at them, maybe you'll find them interesting for your use cases. Like I said earlier, our main use case is user-driven, so user experience is critical for us, it's crucial. So everything is aimed at that. The communication between the user and the database is bidirectional. This means that we need to be able to extract data from Redis graph, convert it into some kind of representation, JSON representation, and send it to the UI. But we also need to be able to convert user interactions and actions into actionable Cypher queries that we can execute on the database. Eventually, we need to take this data that we got from the database and visualize to the user, and we do it by using a JavaScript library called D3. We implemented on top of it, we added some new features, and that's what we use. So that's basically the last end of the puzzle of the data flow. Our future challenges are quite interesting for us because we collect a lot of data, and some customers have retention policies of years. This means that we need the graph to be able to run on 1 terabyte of data per day for up to 5 years. We'll probably split the graph into subgraphs and start pre-processing aggregations on top of it. Up until now, all the aggregations are done in real time. We'll probably use some hot and cold data dumps as well. That's mandatory, I assume. We are in the process of benchmarking, and hopefully when we finish, we'll be able to release at least part of this to the community. Our use cases are comprised of 2 main flows. The first one is creating a new graph with a big amount of data all at once, very fast, and this mimics a user adding a lot of new data into the system and wants to see the graph very quickly. And the other is continuous maintenance and updates of the data, and this simulates collections from the customers, continuous collections. Let's go for a live demo, if possible. I hope we'll have enough bandwidth to do it. So basically, let's take a real-life scenario. I'm a Java developer, and I have some kind of Java application. I want to understand what's happening. I have a crucial bug. I need to understand it. I can just go into Expolog's marketplace. I can find the application that I'm interested in. It can be anything. Once again, we are looking at Log4j, but it can be any kind of big system or application out there. So I can find our application, Log4j. In a few clicks, I can add it, and we'll start collecting the data. Once we collect the data, we can go into the application, and that's what we'll see. We'll see the graph. So this is a real-life real-life log that we took from one of our applications, and we just inputted it into the system. We can take any kind of log and do the same thing, and it will work the same. Everything is configured in that one JSON structure file. So I see that I have a few different message priorities. I can start investigating them to better understand what we're seeing here. I see that I have a few classes. Maybe something is interesting there. Maybe my problem lies there. All of these aggregations are done per type of object. So for example, I have a class. I can aggregate on it differently than I do with other types of nodes, and everything is defined in this configuration file. Let's say that I have a hunch of what's wrong, and I'm trying to better understand it. I can start and drill down even further till the end. And when I find something that I'm interested in, for example, I see that I have a problematic line here, I can just go into the search, and I will see the actual events that caused this data. That's how we propose to do next level data visualization and understanding. Thank you.